Good afternoon, everyone. So I'll be presenting here on the topic of digital twin framework for worker safety using RFID technology for data acquisition. So a bit idea on the what is the current safety or for the past 3-4 years in India and abroad. So ILO thinks that India, like construction is among the top 3 most dangerous occupation having the highest fatality and accident rates with an unproportionately very high amount of recorded accidents globally. And one of the papers by Patel and Jha suggests like 48,000 workers die each year due to these occupational accidents, and 1 in 4 workers die in the sites of the India, basically. There are many regulations and all by OSHA in the USA, BOCW Act. Here in India itself, CDM regulations are there. Other regulations are also there in UK countries. In each country have their own separate regulations as well. But still, instead, apart from implementation of all these things, the accidents keep on recurring. Although the severity and the number of accidents have reduced marginally, but still they are occurring at sites. Now, OSHA, they basically do it in a fatal force, and I will be basically focusing on the falls here and struck by objects caught in between electrocution. These are the major fatalities that occur according to OSHA. So despite all these measures like the guardrails, tow boards, and fall arrest system, fall restraint system, whatever is available in our whatever is available for safety, despite all these, the accidents keep on happening, and the most commonly occurring accidents are occurring due to the falls. And the zero accident vision as per OSHA has not yet been reached in almost all the sites. So we are proposing a third-party intervention in the form of technology, which can like guide or be implemented at site through RFID to bring down the rate of accidents due to the falls. So in technology, construction 4.0 is going on, that is known to all. And there are many technologies like big data, AR, VR. We are known with the terms we are using. In this study, we are using the BIM and digital twin techniques, and for the data acquisition, and for data display and for further analytics, we are using the BIM. And digital twin is a concept, as we all know, is an iterative loop between the physical construction site that we have, and we make a digital technology twin of the same thing, and which will be effective on various analysis and specific decision making, which will be implemented at site. So researchers in the past have applied all these techniques, not all, but we are using only the RFID and digital twin techniques for the worker safety only, from falls and overhead works. So this is a picture just showing the DT concept at a time. That actual construction site will provide the data, and whatever we do as a specific decision making will be converted into the sites. So as an objective, we have to develop the digital twin framework from fall hazards and overhead works only. The scope is limited. And achieve this objective, we are using RFID technology to capture the source data of the location of the materials, equipments, workers, and it will be modeled in BIM, and then specific analysis using the backend coding will be done, and then further analysis will be reflected in the site to the mobile application. So this is the proposed digital framework that we have the actual construction site. We will be enabling the major assets. We will be selecting some assets. It will be equipments, it will be workers, and some of the materials as well. And we will be enabling with it active RFID. And then we will be placing the sensors at particular predefined locations to gather the data of those assets that we are tagging. And then we'll be transferring it to the Excel spreadsheets. And from there, we can transfer it to the virtual model through the Dynamo plugin in the Revit. And further analysis will be done in the form of like automated code checking using either for Revit, we have the Synchro and all we can use. And we have used Python here, normal. And then finally, the whatever notifications we can directly send it to the concerned workers who are under the unsafe zone or something directly at site through the mobile application. So this is some of the steps that have been converted same. First we'll select a site, identify the major resources to be tracked, and then store the location in Excel spreadsheet and represent the various resources in the Revit model that we will be making for the actual site through the Dynamo. And Dynamo will be used for two things, the location and the differentiating the type of resources that we represent in the Revit model. And then we can reload and refresh the model to obtain the real-time data of the location. And further, the proximity, like whatever hazard the worker is in, it will be checked against various codal application and the regulations data. And in case of any non-compliance, the notification can be sent to directly the workers under the hazard zone. So for like a simple case study has been taken to develop this thing. So simply a building a room or something we have taken. And we have taken three resources here, just two materials and one worker. And this Excel shows this location at any particular given point in time, which will be in the next slide. So for converting that Excel location into the Revit model, Dynamo has been used for only these four things: importing the location into the from the Excel, and coordinate conversion into point coordinate systems. And we are separating the materials and equipments and workers as two different assets. And then we are displaying and locating into the Revit model using Dynamo. So in this first case, as you can see, like the workers is there and materials are there, but they are far away from each other. So there is no fall hazard as such. So in this case, there is no threat condition, but there may be a condition. Okay, but there may be a condition where like worker is idle in this case, and one can check for productivity in such a scenario. And this is one of the in the Excel that we shown earlier, we have imported the same thing here in the. So here the one material 2 is posing a threat of fall. It is directly above the worker. So it is worker is under the fall hazard of material 2. So in this case, coding has been done to detect like what are the materials in the vicinity of the area and from their tagged locations. And we are just creating a bubble, safety bubble. And if anything is inside the safety bubble, we'll just pose a notification. Okay, you need to move ahead this much, whatever is the safety regulation that followed inside. So further, we have tested it using two case studies. Like crane is there, workers are working below it. So it is a fall hazard if the workers are within the safety circle of the crane. So they're posing a fall hazard here. So in this case, that only the 3 workers who are within the safe crane radius will be sent a notification on their mobile application, and the 4th worker who is outside but he is nearby, but he's in the safe zone, he won't be sent a notification. So any like avoiding any such false concerns, like any false negative condition, we are trying to eliminate in this case. So, and as a second caselet, we have taken under construction building, and some threats we have tried to impose into the model for the framework implementation. So as you can see, there is an opening, worker is working, workers are working on the edges, workers working on above each other across the edges. So all these are the fall threats, different types of threats that has been taken into this application. So all these workers will receive separate notification, like he will receive like working on the edges, but he will receive that overhead hull fall, and top position worker will receive that you are near opening, please maintain a safety gap as recommended. So all this has been taken for analysis part, but we have not yet tested it on the real construction site. That is one of the things which is we are taking part into this. So in this Dynamo, in this study, Dynamo scripting has been used, and the integration of this will provide a seamless data transfer from the actual site to the virtual model. And this can be expected to locate all the location from the site, and it can be monitored round the clock, the safety. Although the framework has proved effective for the hypothetical studies, validation still needs to be done on actual construction site to be proved essential. And dynamo scripting has been seen to be applied on small construction site for worker safety, but still for this also we had to do too much of a scripting only for these 3 workers or 5 workers or 8 resources or 9 resources. So on a large scale project, definitely heuristic will have to be developed for scripting part alone. So these are the references, and thank you for your time. I'll open to questions.